Welcome back to Tool Bag Tuesday. Today we are looking at a benchtop power supply that'll let us do testing on our electrical circuits before we go put them into a car. Also, if you were working on a car and wanted to isolate a circuit, you could use it as the power supply versus using a battery or a battery charger or something like that. Now, I've had a version of this that I made myself out of a desktop computer power supply, and it's worked just fine for years. I was given the opportunity to pick this one up, and I took the opportunity. So I will tell you, this is a sponsored video. We're back. Kaiweets, however we want to say that, has generously shipped us another product to show you guys, and I'm looking forward to getting to use it here in the shop. So without further ado, I'm going to bring this up. We're going to open it and take a look at it. I never seem to be able to find my knife when I need it, so using a saw blade. Alright. Got us it's a DC power supply. Got the manual. Don't need all this extra stuff right now. We got a power cord. Some leads. Some banana clip with alligator clip on one side. And what else? Got pretty good foam on there. It's pretty nice. It's got, bring this up to you. Got a nice interface. Looks like we have quite a few adjustments. USB, main power button. It's pretty simple. You can look right through the thing, and there's a lot of daylight in there. So the board is down here, and then this is just cooling area. It looks like has a cooling fan in the back and a place to plug in for power. Nice little handle to carry it. So it weighs about the same as the one I made for myself, although it's a little bit larger form factor. However, I'm going to say just the fact that it has this handle on it makes it a little better than mine, because I was always having to try and wrap the cords up and make them fit. Or wrap the cords around it, and then you're carrying this bulky thing. So I want to know. Oh, there we go. LED readouts. Got voltage adjustment. So if we crank it all the way up, we get about 31. Both of them. We have a coarse adjustment and a fine adjustment. We'll play with that a little more here in a minute. And so 32 volts. I can crank this down. And the bottom, run both of them all the way down, 0.02 volts. The manual's got quite a few languages in it, but it's about 8 pages of instruction is all, so pretty simple. Okay, the recommended startup is everything turned all the way to the left. Turn the power on, then dial the coarse current regulator. So we have a red light down here, no light up here. So what they want is to turn this one up until we get some amount of, we get the green light here, of course, and then now we have constant voltage that we can adjust. Then we can adjust our voltage. There we go, 12 volts exactly. So I run the coarse up to just as close as I can below 12 volts, and then dial the fine up until I get what I want. So that's how you set up the constant voltage mode, meaning that it will stay on 12 volts, whatever current it needs to comply with that. So there's also a constant current mode, which would allow you to maintain a specific current coming through the power supply, and allowing the voltage to be variable throughout. I can't really think of a time when that's going to be useful for me because of the way I plan to use this. I plan to set this up, set it on 12 volts, and say I was building an LS wiring harness for an engine, I could have my whole harness, plug all my sensors in, fuel injectors, everything laying on a table, plug in my OBD2 computer, power up the whole system from this, and be able to make sure that I'm not putting so much amperage in there that even if I've got something bad that I start burning up wires, because I can dial the amperage down just enough to trigger whatever system I'm using. And then I can test the whole harness before ever installing it in a car. Same kind of idea with one of the harnesses I'm working on now for a LS swapped into a 96 C10 or Sierra. Anyway, that truck has its own harness, and the wiring's, it is older, but it's still new enough that there's no reason not to go ahead and use the chassis harness wiring in there. But we needed to strip out some of the original wiring that would have run the throttle body fuel injected 6-cylinder in this case. So we had to strip some of those out. So I've got that harness. I can lay that out on a bench, plug in my leads, and go ahead and test every circuit and make sure we've gotten the stuff out that we want and all the other circuits are still working properly. So I think this is going to be a really neat little addition to the shop. Now, just some things to know. It runs on 110 volts. It will put out a maximum amperage of 10 amps, so 0 to 10 amps, and it's all controlled here. We can run our voltage. It says 0 to 30. We saw that it was displaying 31.9 or something. It does have a 5-volt, 2-amp USB interface, so you can plug in, charge your phone or whatever from there. They're saying that their accuracy is plus or minus 0.1%, plus or minus 1. So that sounds like plus or minus 1%. For what I'm doing, I think that's going to be more than acceptable to know that I've got, because I can also test this, and that'd be an interesting thing. Let's go ahead and turn this off, plug in some test leads. I'm going to use the banana clip style rather than a test lead so that I can hook my tester up. And this has alligator clips on the end. So we're going to go into ground and positive. Alright, so we're going to test this against my Syntec, which is a Harbor Freight product. We're going to just see if each displays the same number when we're going through the test. So it does tell you when you are plugging in leads and stuff to turn it off before you plug them in. Alright, so this is saying we got 12 volts, this is saying 12.01. They said they had plus or minus 0.01%, so I realize that's not plus or minus 0.01 volt, but that's pretty damn close. If we tweak this up just a hair and down, yeah, so it's, and I can't tell you which one's more correct. They're 0.01 of a volt difference though, so that's more than enough accuracy for what I'm doing here. And I like that I have a display. On my old computered version that I built myself, I had banana plugs wherever I wanted 12 volts or 5 volts or 24 volts, I believe I could get out of it. And I could also do like negative 12 volts and some stuff that you really wouldn't use very often or ever. But I had no displays. It was just you were relying on the power supply to do what it was designed to do versus having a readout telling you that you're actually getting there. And there was no adjustability. If I started putting a load on, say, a wiring harness and it was drawing down the voltage a little bit, now in constant voltage mode it shouldn't be able to do that, but if I was in constant current mode and I started drawing down the voltage, I'd want to be able to dial that voltage back up, and I wouldn't even know with my other power supply that it was even an issue. So my goal today was just to introduce you to the Kaiweets DC power supply. It's part number 3010DF. Don't have a real good way where I can test it. We can just, and I'm not a destructive tester. I don't tear up people's stuff just to see what it, what's inside it. But you will see this around the shop. You'll see it in some videos just sitting on the corner of a bench. And I wanted you to know what it was and why we're using it. So thanks for watching. I'll see you again next time on Tool Bag Tuesday.